Hello, I'm Dr. Kirsty Miller, and I'm the head of the School of Psychology at the University of Lincoln. I'm going to talk to you today about messing with the mind, manipulating our body experiences. As well as managing the School of Psychology, I also teach and research in the areas motor skill development and sensory motor integration. I'm generally fascinated by how we move and how we understand each other's actions. Movement is incredibly complex, and there are those who will argue that actually it's why we evolved brains in the first place. So if you've got any questions during the talk, then please write them in the chat function and I'll attempt to answer them. Also, during this presentation, I'm going to be asking you to join in and make some particular movements, so please feel free to share any responses to them too. Okay. So I said that some people argue that movement is why we evolved brains in the first place. And some of the evidence for that comes from these, which are sea squirts. Now, sea squirts are from the chordate classification, the same as mammals, fish, birds, and reptiles. The larvae swim around like tadpoles for the first couple of days, then they cement themselves headfirst to the spot where they'll spend the rest of their lives. They begin the rest of their lives by absorbing all of the tadpole-like parts that made them chordates, including their brains. Once they don't need to move, they don't need a brain. I've been interested in how we move since I was an undergraduate student, particularly how we coordinate different body parts during our movements. So actually, how do we use the two hands cooperatively during different tasks? And there are quirks of our motor coordination that mean that particular movements are quite difficult. So obviously I can't see you, but I'd like to think that you'll join into the actions that I'm asking you for. So what I'd like you to do at the moment is I'd like you to continuously turn your right foot in clockwise circles. Okay, so just turn your right foot in clockwise circles. Should be relatively easy. So keep turning your foot in circles and now draw sixes with your right hand. Okay, and what's happened to your foot? Now, if your foot's anything like mine, what will immediately happen is your foot will change to doing anti-clockwise circles. And this is because of the coordinative patterns between our limbs. And this is really what got me hooked into motor control and motor development, is understanding some of these lower order processes that actually help us to move around in the world and to coordinate our limbs. But actually, for the rest of this talk, we're going to talk more about the higher order motor control. So every day we interpret other people's movements. We can gain information from even really vague detail. And in the 1970s, Johansson discovered that actually if we reduce people just to dots, if we remove all of the extra cues around clothes, faces, etc., and we reduce them just to dots by placing lights on the main joints, we can still interpret gender, emotion, actions, lots of information just from these dots. So I'd like you to have a go at these. These are called point light walkers. What I want you to do is to watch these different point light walkers and just to get an idea about what it is you think they're doing. Now, as well as interpreting their actions, you probably find that you can also interpret their mood. Are they feeling happy? Are they feeling sad? Are they feeling bored? And you may also get some understanding of age and of gender as well, just from this really simple movements of these dots. Now, we're drawn to this biological motion, actually from birth. Some work by Simeon and colleagues showed that newborns at just a few days old actually can look at point light walkers. Now, they were really interested in examining this, but they wanted to ensure it couldn't be learned after birth. And ethics obviously means you can't stop a baby from seeing humans within their environment. So what they did is they used point light walker displays of a chicken. So what you can see here in these top three images, you should just about be able to tell that these are point light walkers of a chicken. These ones across the middle are random motion, and these ones across the bottom are actually inverted chickens. So if you turn your head and look upside down, you'll see they look like the top ones. And what they're interested in is, can newborns at a few days old discriminate between biological motion, non-biological motion, and then actually what do they prefer to look at? And they found that not only can they discriminate, they prefer to look at biological motion than random motion, and they prefer to look at upright biological motion than upside down biological motion. Now, all of this suggests that actually this ability to discriminate and to tell biological motion may be innate. And actually, it may have a specialized brain structure that's there just to perceive biological motion. And one of the challenges actually of working online is the removal of all those cues we would usually gain from interpreting other people's biological motion. So for example, in a lecture theatre, I'd get people walking in. I'd also get faces, obviously, but also body postures and shifts of movement, etc., during a talk, which allow me to kind of gauge how my audience is feeling. So movement is complex, and we're generally really good at interpreting the movement of others. But actually today I'm going to talk more about how we understand our own movements. So I know I can't see you currently, but even so, I'd like you just to wave at me with your left hands. Okay, like this. So hopefully you managed to wave, and most of you used your left hands, not your right ones. And for those of you who are watching this with someone else, I'm guessing that none of you actually picked up someone else's hand and tried to wave with that instead, thinking it was yours. And that's because we have a sense of ownership over our own limbs. And you all agree that actually it was you initiating the movement and you waving your own hand. And that's because you have a sense of agency over your movements. Now, if I could reach out and wave your hand for you, you would still feel it was your own hand. You'd still have ownership, but you wouldn't feel that you had waved it. So you wouldn't have any agency because you didn't initiate the movement. So agency and ownership, both of these are key, but where do they come from? So close your eyes and touch your nose. Okay, and now touch your ear. Now, the fact that you're able to achieve this without sight of your hand suggests you actually have an online mental representation of your body posture, and that it's updated with real-time information concerning your body position. If you didn't have this, it wouldn't be possible for you to actually program such efficient movements. So where does this body representation or body schema come from? Now, part of it comes from proprioception. Now, proprioception is information from our joints, which allow us to know the position of body segments. And it's combined with afferent inputs from our skin to give us a sense of our bodies. And we combine this with input from our other senses, from our vestibular sense, our balance in our inner ear, and also from our vision. Now, body schema is this representation of our bodies in space. It's updated during our movement and typically doesn't enter our conscious awareness, but we use it to plan and carry out our actions. If you want to reach out for a drink, you base it on your current position of your body, not where your body was when you put your drink down. So we continually use this to update and plan our movements. It's like a diagram of the body built up in the brain. And our body schema can also feed into our body image. Our body image is that conscious visual representation of the way our body appears from the outside. Now, when I asked you to point at your nose, you could do this and you could localize it because of your body map. Now, if you suffered from something called heteropagnosia, then if I asked you to point to my nose, you might point to your own. You know the location of the body part, but have issues with actually the right body. Now, body schema has to adapt as we grow. So, for instance, my son, who is on the left there, is now 6 foot. His body schema's had to change and update as he's grown. We also have to adapt our body schema for more sudden changes such as pregnancy, and it can also adapt to incorporate tool use. So we can incorporate that tool as part of our schema. And it has to update continually because we move continually. But this updating of our body schema can go wrong. And we're going to have a quick look at 2 case studies where this has occurred. So the first is the extraordinary case of EP. EP was a 42-year-old woman studied by McGonigal and colleagues, and she suffered a stroke during a procedure to clip an aneurysm. After this, she started to experience a third ghost arm that mimicked the previous position of her real left arm. And also, occasionally, she had a ghost leg as well. And it appeared that her body schema wasn't updating as expected. So sometimes when shopping after her operation, she'd sometimes feel like she'd taken somebody else's shopping bag because the third arm made her feel as if she was carrying 3 bags. And while this caused her some embarrassment, actually, she never attempted to rationalize or ignore the presence of this ghost arm. And if she had continual tactile stimulation, so peripheral electrical stimulation to the left arm, this would prevent her from experiencing this ghost. Now, this ghost arm or ghost leg in this case are known as a supernumerary limb. So what happens normally is if I move my arm from here to here, my body schema instantly updates and I know my limb is now here. Suggestion is that with supernumerary limbs, the body schema isn't updating, so you get left arm here as well as a new arm in this position. So in the 90s, Sellal and colleagues studied a 77-year-old man with a complete left sensory motor hemiplegia and left neglect. And for several weeks, he reported the existence of up to 6 supernumerary phantom limbs. Okay. So it's a little bit about ownership and that body schema and how it fits, but what about agency, that sense of ownership over your movements? So Della Sala and colleagues took their patient GP who had anarchic hand out for dinner with her family. They were discussing the implications of her medical condition for her and for her wider family, when out of the blue, her left hand took some fish bones that were left on the plate and put them in her mouth. Now, she was very embarrassed about this action, this behavior that she didn't intend to do. Then a little later during the dinner, her left hand took the ice cream that her brother was eating. Her right hand immediately intervened to take it back. And what ended up happening is the ice cream falling to the floor. She apologized profusely for the behavior of her left hand and claimed that it had a mind of its own and often did what it pleased. Now, individuals with anarchic hand are aware of their bizarre behavior, but actually they cannot inhibit it. They often refer to the feeling that actually their hand behaves as if it's got a will of its own. But they don't deny that it's part of their own body. So they have ownership of the limb. They feel it's theirs, but they have no agency of the action. So the bewilderment comes from the unwanted actions, not as a sensation that the hand doesn't belong. Now, what this condition does is it seems to demonstrate that self-ownership can be separated from awareness of actions. So just because you are aware of an action doesn't mean you feel that you started that action. It's the equivalent of me waving your hand. You're aware that your arm has moved, but you don't feel ownership over that action. So patients affected are aware of the actions of their anarchic hand, and they know it's their hand. They don't believe it's a robot counterfeit. It's a different condition where you don't believe your limb belongs to you and you think it belongs to someone else. But in this case, they don't disown it. They feel it's theirs. So what could be going on? We don't have all of the answers, but we think it might be related to the supplementary motor area, which is an area in the frontal lobe that plays a role in the execution of movements. It's thought to be responsible for converting intention into self-initiated action or involved in the selection of what movement to make. Now, individuals with an anarchic hand, when we've looked at brain scans, it suggests that actually there's not activation in the SMA first, or SMA is damaged. So we're not seeing this intention to act. And actually, if there's bilateral damage, so damage in both sides of the brain in the supplementary motor area, then what we can see is something called utilization behavior. This is kind of what GP was doing. So utilization behavior is when you act on an object as an object would normally be acted on. So if you see an ice cream, you'd normally take it and eat it. That's a utilization behavior. Now, obviously, we'd normally inhibit acting on an item that wasn't ours. And it could be that inhibition goes away. Okay, so anarchic hand, this lack of agency over movements. Now, I mentioned that sometimes you could deny the limb was yours, and that is a condition called somatoparaphrenia, where you deny part of your body belongs to you, and there are issues with ownership. So our ownership and agency appear to depend on having an accurate body schema, as well as other elements. And as a psychologist, there's nothing that is kind of more enjoyable occasionally than just messing with an accurate body schema in order to see what happens. So what I'd like you to do is to cross your arms like this and intertwine your fingers, then pull your arms back up and through. Okay, so you end up with your hands up like this. Now, if you have someone with you, then what I'd like you to do is get that other person to point at one of your fingers and tell you which finger to move. So don't touch it, just point at a finger. If you're on your own, like I am, you can just look at one of your fingers really hard and try to move that finger that you look at. Now, if I practice really hard, I can move the right finger because I've done this a lot, but often you'll find that you move the wrong finger. And now this is because normally you'd be pointing at the other hand. So visually, it would normally be the other side. Now, if someone touches your finger, it becomes much easier for you to actually move it. Okay. So, anarchic hand, supernumerary limbs, heteropagnosia, somatoparaphrenia, all of these are higher order motor disorders, and they involve something going wrong with the processes that allow us that sense of agency over our movements and that sense of ownership over our bodies. Now, we don't yet know what goes wrong, but the issues might be about integration of information. They could be around that integration of vision and proprioception, which is what we're playing with a little bit when we do this. It could be about planned action. It could be about the inhibition of movement. And there are different ways for us to try to study actually what may be going wrong and to get a better understanding of the importance of these different elements. Okay, so one way to gain a better understanding is to use multisensory illusions to investigate the complexities of ownership and agency. So there is a very famous study called the rubber hand illusion that you may have heard of, which was developed by Ramachandran. And this is where we time stroking of a real hand and a fake hand with only the fake hand in view. And that's what you can see here. So this participant can see the fake hand, his real hand is out of his eye line. And what happens is the experimenter will stroke the fake hand and the real hand at the same time. So there is that common timing between the two. And what happens is you begin to feel like the fake hand is yours. And then after you've begun to feel like the fake hand is yours, we threaten the fake hand in order to look at things like galvanic skin response to see whether we're seeing the same level of response that we would if we threatened your real hand. And this can give us an idea about ownership. We also ask you a series of questionnaires around how you kind of feel about the hand, whether you feel a sense of ownership, whether you feel sensation from it, etc. So I will show you this video. This is a more extreme version by Botvinnik and Cohen. So the stroking of the two hands, and then a threat. Now that threat is a little bit of a shock. So actually, you're always going to react to somebody suddenly flying into your view with a fork in their hand. Often the threat isn't that much of a shock, but it's one reason why we compare it with a threat to the real hand and a threat to the fake hand without that sense of ownership being taken by you actually stroking both simultaneously. Now, what we found in our lab is that not only can you get people to feel like a hand that looks like a hand like this one is their real hand, but actually you can make hands or hand-shaped objects and other elements and get them to feel that that belongs to them. And so one of my dissertation students made a hand out of Play-Doh and pencils. So it was hand-shaped, but definitely not really hand-like. And by doing this, timing of the stroking of the hand and the fake hand, matching the visual input and the tactile information, the participants started to feel like this fake hand was theirs. And then when we threatened that hand with a hammer, actually we saw a galvanic skin response that suggested a feeling of ownership over that limb. But we did it in a slightly more high-tech way than the version you've just seen, and that's using this, which is the mirage. So what we can do with the mirage is we can make the information you receive about your limb not line up. So we can make it so that the visual information, the proprioceptive information, and the touch don't all agree. Now, the mirage was created by Dr. Roger Newport while he was at the University of Nottingham. He's now at Loughborough University. And it's a system of mirrors and lights and cameras that allow us to manipulate the information you receive and then investigate the impact of manipulating that information. So we used this when we did our version of the rubber hand illusion. And we've used this in many sources. We take it to public engagement events. We get kids to play with it quite a lot. See the different reaction, the developmental stages of kind of how there is this interplay between vision and touch and proprioception. So with the mirage, we can manipulate the information that you receive about your limb. And this allows us to investigate the relative importance of different sources of information. So for example, which is more important for you to know where your hand is, vision or proprioception? So right now, if I ask you where your hand is, it's probably not in your visual field. So it's probably proprioception that you're using right now. But which matters more? Which will you trust more? Visual information about your hand position or proprioceptive information about your hand position? So the disappearing hand trick is one way to look at this question. So this is what happens. So they put the hands in the mirage box and they have to hold their hands still. They have to not touch the blue bars. And what it appears to the participant is that the blue bars are slowly closing in and that what they're doing is moving their hands inwards so that they don't touch the blue bars. But actually, despite the fact that these seen images of the hands are moving inwards, what the participants are actually doing is moving their hands outwards. And they're moving them outwards to try to keep them in. So they end up further apart without the participant actually noticing. And this is where we're manipulating the images that they're having. So the right hand disappears. They need to touch their right hand. And they can't find their right hand. So that's the view from the top. But actually, what does it look like when you watch a participant do it? So she's just been asked to reach out and touch her right hand. Okay, which is one of the most fun things about the disappearing hand trick. This video is courtesy of Newport, Gilpin and Preston. One of the most fun things with this is it doesn't matter how many times you do the disappearing hand trick. I've had this done on me so many times. I've done so many other people. It still works. You know exactly what's happening, even when you know that despite the fact you feel like you're doing this, in reality, you're doing this. So then when your hand disappears and you have to reach out and touch it, you think to yourself, I know my hand is further over than I think, and you still can't find where your hand is. And what we can do with this is this tells us that vision is really important and that we all tend to over-rely on visual information rather than proprioceptive information about our limb position. And then we can look at that. And is that the same for all people? Is that the same for all age groups? Is it something that changes with development? Is it the same for all individuals? So, for example, the work of one of my colleagues, Kirsty McKenzie, is looking at individuals who score high in terms of autism quotients. And actually, we find that individuals who score higher in terms of autism quotient are not as fooled by the disappearing hand trick and some of these other illusions, because they don't appear to rely as heavily on the visual information as those who score lower on the AQ. So we can see that we rely on vision over proprioception about our limb position. What about touch? Can visual information give you tactile sensation? That's what this crawling skin illusion study has looked at. So this is how your hand would normally appear within the mirage. It's not exact. In terms of timing, it's really close. It's within 20 milliseconds of you moving your hand, which is not a timing difference you're consciously aware of. You can see it's not exactly the right color because the images are much more kind of black and white. But in terms of lightness, etc., it's kind of there. Now, this is the crawling skin illusion. So here you can see the hand looks very different. So in this study by Mackenzie and Newport, what they were interested in is if this crawling skin illusion actually changed the somatosensation, so that tactile information people were reporting about their limb. What they found is that there was no difference between A and B. So A is the hand as it would normally appear, B is darker, so no difference here. But this reporting of somatosensation, which was illusory because we're not doing anything to actually change we're not touching the hand in any way, was much higher in C. And participants who actually were reporting less ownership over their hand, so we give them an ownership questionnaire. Does this look like your hand? Do you feel this is your hand? And the participants who felt less ownership over their hands actually reported feeling more visually induced sensations. So, for example, that's not my hand, but it's tingling. So this suggests that top-down visual knowledge actually overrides the tactile sensory input that participants were getting. So the final example of the mirage that I'm going to give you is this one, using finger stretching. It's one of my favorites. This particular study was by Pereira, Newport, and Mackenzie. And they were questioning, do you really know how long your fingers are? So image A here is the normal length of the finger. B is stretched. C is shrunk. D, the hand itself has been stretched. And with E, the hand itself has been shrunk. So what we do with this within the mirage is, as you can see in the first picture on the left here, if you put your hand into the mirage, what we do is we hold on to the end of your finger and we pull gently on the end of your finger. And as we do that, the information that you see on the screen shows your finger stretching. And it doesn't matter that in reality, you know, it's not possible for your finger to be stretching. That combined information from the tactile feedback you get from the end of your finger, plus the visual information that you get of your finger stretching. Now, of course, if you pull on the finger, you can feel a little bit of stretch on the joint, creates a really strong illusion of your finger stretching. So we have done this in the lab with different projects in order to look at things like pointing. Do you then point as if your finger actually is longer? So are we influencing your body image or your body schema when we stretch your finger? But this particular study by Pereira et al. Was interested in, do you know how long your fingers are? So they would use these illusions, stretching, shrinking, stretching hand, etc. And they would get participants to fill in questionnaires on ownership and also the illusion strength. How strong were they perceiving this stretching or shrinking? And then what they would do is they would go to resize the finger. So if it's been stretched, to go to push it back in to make it the right length again. And they would ask the participants to say stop when you feel like your finger reaches its real length. And what they found is that 100% of participants actually overestimated the perceived finger length. If it was a shrunken finger to start with, they underestimated their finger length. Stretch hands, we see overestimation. Shrunken hands, underestimation. So actually they were very poor at putting their finger or their hand back to the right size. So not only did 100% of participants overestimate the length of their finger if it had been stretched, but actually they overestimated the length by about 50%. So it's a very strong illusion. And again, suggesting that this visual information is incredibly important when it comes to setting our body schemas. Okay, so why does it matter? Why does all of this work that we do with the mirage? It's lots of fun to do, but why does it matter kind of in the grander scheme of things? So as we said before, these multisensory illusions can help us to answer questions around higher order motor disorders. So they can help us to try to understand what the most important elements are for accurate ownership and agency. And they can also give us insight into what may go wrong in some individuals. So for instance, with supernumerary limbs, we can give you, using the mirage, an additional limb next to yours. We can change how far away it is from your real hand. We can change if it moves at exactly the same time or not. And we can look at things like ownership. But actually this type of research is useful for other ways as well. It's important that we understand agency and ownership in order to be able to understand other things as well. So for example, on the left here, we have Zion Harvey, and on the right, we have Corinne Hutton. Now, both of these individuals had double hand transplants. Zion in 2015 when he was 8, and Corinne in 2019. She was the first double Scottish hand transplant. And actually having an understanding of what's important in terms of ownership of our limbs can help to inform things like prosthetics and also things like hand transplants. How important is it that the skin color matches? How important is it that the size is relevant? Their first successful hand transplant was in 1998 to an individual called Clint Hallam, and he became mentally detached from his limb. Now, there are a number of reasons for this, some of which was failures to take the immunosuppressant drugs. But one thing he reported was that the size and the color didn't match. So he didn't feel that sense of ownership over the limbs. And this also fits with prosthetics as well. I mentioned earlier a study by one of my students creating a hand out of Play-Doh and pencils and seeing if they could get somebody to feel ownership over it in a version of the rubber hand illusion. As well as that hand made of pencils and Play-Doh, we also had a very lifelike hand that actually came from a site called Pound of Flesh and was for practicing tattoos on. But it was incredibly lifelike. And people didn't feel as much ownership over that really lifelike hand as they did over the hand made of Play-Doh and pencils. I think this is maybe because of something called the uncanny valley, where actually it was too lifelike. It was a bit weird because it didn't look like their hand, but it did really look like a hand. So it became a little bit odd. So actually this type of work can, in the long term, kind of help her to inform us in order to be able to make changes around different ways to support individuals with amputations, as well as giving us a much better understanding around what is important in terms of ownership and agency of movement. So thank you very much for listening, and I hope you enjoy the rest of your week.